BluntCut MetalWorks, July 6, 2022. I fixed the vertical impact toughness tester. Now it's using the striker, which is carbide head, with ISO geometry, which is 2 millimeter radius. The result normalized to this cross section here, and the mass of the striker is 4.4 kilograms. For the reference, which is the conventional heat treat of 8670, got retested because the previous video, the head of the striker was 1 millimeter radius. So the head actually have very narrow force focus, also dig into this sample and create, pretty much initiate a shorter crack line, a lot of compression, and then create tension on the opposite side, which is, it break a little sooner. And I only have these two hardness, 61 and 62.5. And here the number of samples that were tested, average over, and then this is the average number. So for 61 Rockwell, you got 24.8 foot-pounds force. Something LBF is the gravitational force versus LBS is actually the F is the gravitational, the S is just a standard weight force. And for 62 Rockwell, and compared to the BluntCut MetalWorks sequence, the one I would, and I only have one set left, which have 3 samples at 60 Rockwell, and that's about 18.8 foot-pounds. So this 60 at that amount. So it was so we'll be doing a little extrapolation here. Conventional heat treat at 60 Rockwell, it may be 28, probably about 28 or so foot-pound. So compared to 2, the BluntCut MetalWorks sequence is quite a bit less. Let me see, 18, say 27, for example, then it was 2/3. So it's about 2/3 as tough as a reference one of 8670. And then I did another experiment, and I call A here, and here the soak at 1500 degrees, for 15 minutes, and 8670 only come out at 57.5 Rockwell, and the foot-pound break at just 28.8 foot-pounds. For the 1095, and the result now is 25.2, but this is 57 or 57.5, and this is 60. So, but if you recall just a moment ago, they extrapolated 60 Rockwell for conventional heat treat to 60 Rockwell, and I will get about say 28. But now for this only at 57.5, which would be about 2.5 Rockwell less, and the foot-pound was about the same. So I expect, because again, the more you go toward iron, more iron into or ferrite into your sample, then actually you don't keep on increasing. You need the strength. You need actually the actual martensite, a lot more martensite, rather than just ferrite. And then did another sequence, and this time we got 60 Rockwell here for 8670. We got 4 samples, and the result at 33.7 foot-pounds. So recall again, I extrapolated value up here as about 28 foot-pounds. Now, this sequence here, B, get better result. We got about a little bit 5 pounds, 5.7 foot-pounds improved. interestingly here, compared to the 1095 sequence, notice the hardness is a 63 Rockwell, a 35.1 Rockwell. And I got actually a sample, so they average over. So some number are very high, some a little low, but average out to be 35 foot-pounds. Compared to, well, on 8670, the highest for, again, I only have one number out here, at 33.7, but that's 60 Rockwell, and this is 63 Rockwell. This number here, I have two blades, and I will test the blade in terms of how it performs, and in the separate video. If the edge strength and the toughness, in other words, the toughness, the impact number of toughness very high, and the strength they actually are 63 Rockwell. Rockwell hardness is only partial of strength because they measure the displacement. So therefore, they're a little bit more complicated. They're missing variable in terms of the overall strength. So we'll see how the blade perform, and then if they perform well, then I would do sequence B and incorporate it or integrate it into the full sequence that I would do for 1095 or other low alloy. Thanks for